use the Pythagorean theorem to find x and y. All right, so how do we find x and y? Let's start with x. We want to find x here, which is the, we got this trunk. It looks like a big trunk or something. And this side, so x, if we see up here, there's a right triangle up on the top of this trunk, isn't there? This side is 15. What is this side here? Well, it's got to be that 25, doesn't it? So let's put that in there. It's 25. So this is a right triangle right there. So we can say 15 squared, right triangle, we can use Pythagorean theorem. A squared plus b squared is c squared. And which one is the c? It's the one across from the right angle. So 15 squared plus 25 squared is x squared. X is the c. So use your calculator there. And I'm getting 225 plus 625 is x squared. Add those up. And we're getting 850 is x squared. So now x squared. So now they want us to, we got to take the square root of both sides. So now how do you square root 850? Well, you got to break it down. You know it's 85 times 10 because that 0 at the back. Just use your calculator. Divide this by 5. 85 divided by 5 would be 17. So we got 17 times 5, and this is 5 times 2. So I broke down the square root of 850. So it becomes the square root of 17 times 5. This is times 5 times 5 times 2. That's what x equals. And then remember how square roots work? They're a 2-for-1 deal. So 2 5s inside, ship 1 5 outside, and they're gone. So that leaves us with what? What does that leave us with? That is 5 square root, and then the 17 and the 2 remultiply inside to be 34. So there's x, 5 root 34. Now, all that's for x. Now we got to go back and find y. To find y, notice that y right here and up there is part of a right triangle that goes sort of diagonally through the middle of the trunk with the right angle right there. So that means, again, we're going to use the Pythagorean theorem, because whenever you have a right triangle, you can use the Pythagorean theorem. A squared plus b squared is c squared. The one that is c is the one that is across from the right angle. That'd be y. So this is going to be y squared. The other two sides are x squared, right? This side here is x. X squared plus 9 squared is y squared. Now we know x. Let's grab it, bring it up here, plug it in. That's 5 root 34 squared plus 9 squared is y squared, right? Because we found x previously. Now, how do we simplify that? Well, what you do is you square the 5. 5 squared is 25, and you remove the root. Remember, squaring and root, like over here, squaring and roots cancel each other out, so it'll cancel that out and make it a regular 34. And 9 squared is 81. Did you track with that? It squared the 5, and it removed the root. It didn't square the 34. We don't put a square on the 34. Why not? Because the root and the square canceled each other out over the top of the 34. So it just became a regular 34, the root and square canceling each other out. So 25 times 34, what's that? 850 plus 81 is y squared. And I'm getting 931 is y squared. And then we're going to root it. And so y will equal the square root of 931. Now we got to break that down. I have no idea what goes into 931. Let's try dividing it by 3. Doesn't go in. You can try 3. Or 5 doesn't go in because it doesn't end with a 5 or 0. Try 7. Yeah, so I divided by 7. And that went in 133 times. And divide that by 7 again. And that's 7 times 19. That's a weird number. So that becomes y equals the square root of 7 times 19. And those two 7's inside send out a 7, and they're gone. The 19 stays inside. So y is 7 root 19. So there we go. There's how we find x and y. I use the Pythagorean theorem twice on that one.